All right, so here in this section, you're going to find problems where you calculate the enthalpy of a reaction using two different ways. We'll use what's called the enthalpy of formation or heat of formation. And, and so in this case, then what we're going to do is we're going to then look at those kind of individual steps. So first, the heat of formation is the energy it takes to form 1 mole of that from the elements. And so those are the thermodynamic values you find and give us a lot of cool ways to calculate things. And so the classic kind of way we do it, looking at a reaction, is just do those coefficients of products minus reactants. And so often it reduces down to this simple relationship. And so if you're given a problem like this, then you just then take the products, the coefficients, and substitute in those numbers for the products, and then do minus the reactants. And so substitute those in, and then since this is elemental state, it'll be 0, and then you can easily solve for it. So you can look at this section then for more examples if you want to go through that. The second type of problem you find is what we call Hess's law. And in those are where you're given a bunch of reactions with enthalpies, and then you're going to add them up in a way to get your overall reaction. So this is kind of a weird starting one, but if we were wanting to solve for this one, then we just start looking, where do we find this? We find it here, so it'd be H1. And where do we find this? It's still H1. And looking here, then we find this here, so it would be H3, and this is also H3. So it's not really identifying where we're using this, and it's because we formed this iron in the first step, and then we need the second step to convert it over. So you wouldn't be able to use this shortcut method I'm going to show you, but nonetheless, it will reduce it down and make it a little easier for you, so less steps. So here's an example, and this works for most of the problems that you're going to find in the chapters that we have in Gen Chem. So if we have these two reactions given and we want to find the enthalpy change for this reaction, then we just look to see, well, where is carbon monoxide? And we think about reaction 1, reaction 2. And so carbon monoxide is a product here in H1. So we need to flip it around. So it'd be minus H1. And it's a product here, for 2, but we want it for 1. So we're actually going to take a half of that, half of H1. And then we have oxygen. Oxygen is present in both, so it doesn't identify, so we can't use that. So then the carbon dioxide, it's only present here. And it's a product, that's what we want, and it's 1-to-1. So we simply add H2. And now if we scroll through and we look at how they do it, then what they're going to do is they're going to do write it out the long way and kind of add it up and get this a different number. But then they come back and they're going to scale it down to get to 1 carbon dioxide. And so a lot of times, if you scroll through and you look at some practice problems, you'll see that simple H1, H2 addition, people get it down and they can almost do it in their head without. So I hope that helps, and then let me know.